In this video, we're going to consider some analogies for electrical circuits. And an analogy is where it's a type of model, and it's where we use some everyday events to try to explain something that's going on. And with electrical circuits, it's nice to picture something that's happening. So for current, we're going to picture this group of children. And for current, we really want to measure how many electrons go through the wire each second. So our children are representing our electrons coming out of the battery and moving through our wires. If we were using a circuit, we would measure them with an ammeter, but we could count the children, and you'd measure them in amps or amperes. So let's have a look how this analogy would work for a circuit. So here is our circuit. We have a power source here, so our battery, and you can see our children are moving around the circuit. And there they go, they're all there. The same number go through the wires all the way around until they reach the bulb. So this is the symbol for the bulb, but you'll notice if we're counting how many electrons enter the bulb, then exactly the same number of electrons or children exit the bulb, and they keep working their way around the circuit until they get back to the battery. So in terms of children, they're running around the wires or running around the corridors. They go through the bulb. That might be quite hard work for them because the bulb is an area of resistance, and then they run through the wires again and back to the power source. So if we were to actually measure them with an ammeter, we would notice that the value for the amps through this wire would equal the number of amps on this wire. So the number of electrons would be the same in both wires, or the number of children running through the wires would be the same. We can look at slightly more complex circuits. Here we have two bulbs and they're connected in parallel, and you'll notice that at the top here we have a power source just like before, but this time we're pushing out two queues of children. And as they go around the corner and they reach this point here, there's a choice. So some of them go through one bulb and some make their way around the corner and they go through the next bulb. So we've got two globes in the circuit. They both need to be fed with a supply of electrons or a supply of children working their way through, and then those children join up so that you end up with the same number that we started with going back towards the power source. So hopefully that analogy of children running through wires helps you to understand the number of electrons moving through wires, and therefore helps you to explain how current moves through wires. So give yourself a little rating. Did you get it? Are you not sure? Are you still confused? So what is voltage? Let's use an analogy this time of chocolate biscuits and a hungry baby. And we're going to need to introduce a friend of mine here. We've got Mrs. Volt. She's going to be used to measure how much energy each electron has gained or lost as you go across a component. You do that using a voltmeter, which is volts, measured in volts, but Mrs. Volt is going to do this for us. So we're going to start off by considering how much energy does an electron have before it reaches a bulb, and how much energy does it have after the bulb, because we're interested in the voltage that has been dropped as we go through a component like a bulb. So let's have a look at our baby eating chocolate biscuits. So here's our baby. Our baby is representing our bulb here, eating up the voltage, and our battery is generating the voltage. So out of the battery is coming a plate with 12 chocolate biscuits on it. And this baby is enjoying those chocolate biscuits. So when we get Mrs. Volt involved, she will be able to count that and say, hey baby, you ate 12 chocolate biscuits, because the plate was empty. After that voltage went through the bulb, all the biscuits disappeared. So if we were to place a voltmeter there, instead of Mrs. Volt, she would say 12 have gone through that bulb. Let's look at a slightly different analogy. We put two bulbs next to each other. Out come 12 chocolate biscuits from the battery. So we've got 12 chocolate biscuits on our plate, but now we have 2 hungry babies because we have 2 bulbs in our circuit. So hungry baby number 1 eats half of the chocolate biscuits, and hungry baby number 2 eats the rest of the chocolate biscuits. So the chocolate biscuits have been shared between the 2 components, which is exactly the same as what happens with the volts. The volts get shared between the 2 components, and Mrs. Volt is able to work out that if we started off with 12, then each of those bulbs uses up 6. You can also look at the voltage in other components. So we're going to have a look here at how much energy do those electrons have before a battery, so a power source, and how much do they have after the battery, because that would be the voltage gained. So let's have a look at what happens if you put a voltmeter across a battery. Here, if the battery is putting out 6 chocolate biscuits, there's 6 chocolate biscuits, then the Mrs. Volt can count 6 have been added, so that's 6-volt battery. We can also have a look what happens if you have 2 batteries side by side. One's putting out 6 chocolate biscuits, and the next one is putting out 6, so now we have 12 chocolate biscuits. So if you add 2 batteries together and keep them in the right direction, you can increase the voltage. And the last thing is, if Mrs. Volt has a look at what happens in wires, you will notice that wires, 12 biscuits, 12 biscuits, 12 biscuits, wires do not use up voltage. So there's no change. So if there's no component, you do not lose any voltage. So rate your understanding using these analogies. Did the biscuits and the hungry baby help you understand voltage? You get it? You're not sure, or you're still confused?